So my name is David Scheer. I'm a product manager at Autodesk, and I've been working on the lighting analysis for a Revit tool over the last year. We released the first beta version about a year ago. We've been working on it steadily over the last year. So I'd like to talk about not only daylighting analysis in Revit, but what that means what it means to bring daylighting analysis to architects and the architect's design environment. We started out using a metric of illuminance, which is the amount of light that is falling on a surface. It's the amount of light available for use on a surface. And illuminance and luminance are two metrics, two measures that are normally used in daylighting. Luminance is the amount of light that's coming off of surfaces. It's view dependent, and illuminance is the amount of light falling on a surface. So adding a benchmark to a metric allows us to have a judgment of goodness or badness. So if we have a metric that is, say, between 0 and 100 and we get the answer of 66, well, I don't know, am I okay or not? So we need to have a benchmark that says what is good enough. 67 is good enough, great, 66, we passed. So we need a benchmark to measure whether things are good or not. There's some typical recommendations for illuminance levels from the Illuminating Engineering Society. These are for different types of activities. You can see that a lot of the passive activities and outdoor activities are much lower. These are foot candle levels. And the fine detailed work like drafting and fine assembly tasks have much higher requirements. But you can see a lot of these numbers are between 5 to 50 for most uses. So we wanted to start out with a tool that automated a process that a lot of architects need to do, and then also integrates illuminance data into the design process. So we started out with the LEED metric for daylighting. LEED has both a metric, illuminance that they're measuring on a work plane at 30 inches, and it's got a benchmark threshold to pass LEED. So to make this simple, there's a few options, at least for 2009 8.1 daylighting credit. There's measurement on site, which doesn't really integrate daylighting into the design process. It can only be measured after the building's built. There's a prescriptive method which doesn't really integrate precisely with the detailed workflow of an architect. And then you've got the full simulation method, which allows users to simulate wherever you are in the design process, see how you're doing, and make adjustments to change it. So it really puts the daylighting analysis process right into the design process. And you can see on the right-hand side represents the different phases of construction. We're seeing that we can actually pull daylighting analysis all the way back towards conceptual design. As soon as you've got a Revit model that's built with detailed geometry, you can start doing daylighting analysis. And then since that information is coupled with the BIM model, those analysis results are going to be part of the design process all the way through construction documents. Now, another value with having the analysis and the results integrated into the BIM process is that we can also have other tools like solar analysis, which we actually just released in labs yesterday. Lighting analysis, and then energy analysis, which Ian just talked about. All these things are operating on the same architect's model and are keeping up with the revisions that are done in the Revit model. So if you need an answer about how your shading device or your affects your daylighting and your solar radiation on your glazing, you can answer those questions with the same model. All right, so let me talk about the lighting analysis tool itself and how we've tried to incorporate some of these concepts into the analysis tool. So what we're trying to do here is we're trying to create the baseball, right, for the architect. So the lighting analysis tool has a very simple front end, a button on the toolbar that has run analysis and generate results buttons. It's really a two-step process at the highest level. The analysis window, which gives very few choices, just analysis type, and then everything else is automatically set up for that analysis type. And then the output artifacts being artifacts that are integrated into Revit are shown on the Revit model. So the results of the analysis can not only be used to judge the goodness or badness of your current design, but can be used to inform what should be done spatially on the design to improve that performance. And then the final piece of results is giving the full room by room performance for each threshold required for the lead submission spreadsheet. And currently we do that for the 8.1 credit for version 3 of lead and the version 4 option 2, which is the point in time analysis. We currently don't do daylight autonomy. And then also, of course, being everything integrated into the Revit environment, you could create layouts or output in whatever form you like. Yeah, actually, go ahead. I'll answer a couple questions. All right, thanks. Yeah, so the question was, do we offer the ability to choose occupied spaces, regularly occupied spaces or not? And where that is in the schedule. I'll show a live demo if I can a little bit later, or you can look on the computer out here. But on the schedule, we use rooms to recognize the detailed distribution of spaces. Those are normally used by architects for labeling and space planning and takeoffs. And when we run the model the first time, we assume that all rooms are occupied, and then after the analysis, you can go in and uncheck the rooms that are not occupied. And also on the schedule, you can choose whether a room has automated shades or not, so you can ignore the above the high threshold. Basically, after you've run an analysis, the raw results are available in your Revit model and saved with your Revit model, so you can manipulate settings on the schedule and not have to rerun the analysis. You just regenerate the results very quickly. So let me see if I can play this animation. I'm going to stand out here. So this shows the Yeah, right now it's a plugin, and it's available in two places. It's available through Labs. It's a full release now, but it's available through Labs, and it's also, we've got our own product page. So if you do a search for lighting analysis, Revit, that should be the first search item. And it's a free download, it's a free plugin. We monetize it by charging cloud credits for analyses, but there's always a free level of analysis, so you can get used to the tool, get your model set up so that it's working properly, you know your materials are right before you run an analysis that's paid. So basically right now, anything under 6,000 square feet, you can do a very detailed analysis on a 1 foot grid. And anything under 25,000 square feet, you can do a 6 foot grid for free. And then above that, it's pretty cheap, really. I think it's 1 cloud credit, which is about $1 for every 3,000 square feet for a high resolution, and about $1 for every 12,000 square feet for a low resolution. We've done calculations with people on what their expectations are for applying daylighting to most of their projects throughout the year, and generally we found that the pay-as-you-go system is a little hard to get used to. Generally the cost for a year is going to be less than what they would expect to pay for a tool like this, and then far less than what they would save in the time of having to do all the hours and hours of model setup and waiting and babysitting the machine and translating the results and displaying them in the model. So we're hoping that the automation of the tool pays for the charges that we have. Yeah, sorry, you first? Good question. Any vertical plane analysis? We don't have a vertical plane analysis right now. Right now what we do is we run an analysis on a set of points that is offset 30 inches from every floor plate. So anywhere you use a floor in the model, you'll get analysis points. If you write to us and let me know like what kind of analysis situation you'd want that in, we could certainly implement something like that. Yeah. Yeah. Right. So are you talking about the color scale? And are you talking about the legend itself? Okay, that's a problem that's inherent in the AVF, which is a platform that we use in Revit to show the data. It's called Analysis Visualization Framework, and it's used for all kinds of stuff. You can basically, any data that you have, you can display in a bunch of different ways on surfaces in the Revit model. So we're stuck using that. That's our #1 question for that team to improve. Yeah, so unfortunately, one workaround that I like to do is to open up the analysis display settings dialog, and you can basically take a screenshot of the gradient settings, and that makes a much better scale that you can put in and you can actually put that screenshot in your sheet or in your images. The analysis display settings is a place where you can actually create your own gradient display. You can change to show points rather than a gradient. You can make your own color combinations. So now it's the analysis display settings. Basically, if you go into the properties of the view, you'll see up in the top the analysis display settings. Yeah. Any other? Yeah. Yeah, please. Yeah. So the plugin itself is free for anyone. The cloud credits are where you're charged, and for students, all cloud services are free. So, yeah. Yeah. Good question. So 2 questions. One, when do we plan on doing daylight autonomy, and does it tie into the energy analysis? So both of them, those are very important to us, high on the list. So daylight autonomy, everyone's asking for it, everyone needs it. So for sure, you'll see that as soon as we can. As far as tying in with the energy analysis, again, another thing that we'd like to have very close coupling between the two. Since we're both of them are in the cloud, we've got a natural way to start tying the data together. Right now, the glazing specifications, for instance, are defined in a different way for lighting analysis than they are for the energy model. So in that way, they're not tied in directly. You'd have to copy the same settings in both. But again, we've heard that request, and it's another goal of ours for sure. Yeah. Yeah. Right. Great question. So the calculation engine is based on a method developed at Cornell called multidimensional light cuts, and we've taken the research that was done on that and turned it into a proprietary analysis engine. And it's a very physically accurate. When people ask us how many bounces, we just say, well, we do them all. We do all the ones that are important. The main part of the process is that we first go through figuring out what bounces we need to do, and then we do none or one where they're not very important, and we do 10 or 50 where it's very important. So it is a ray tracing process, but there's basically a filtering process that we go through first. And I've got a few slides on that. If you want to see those later, I can show you out there. Let me see. Any other questions before I move on? Okay. Yeah. Yeah, for the lighting analysis, no, there's really no changes between 2014 and 2015. Yeah, they both work about the same. Yeah, the main changes between 2014 and 15 has been the energy analysis model generation has been a lot of significant changes there. So I'm going to actually move through some of these slides quickly because I've gone over a lot of them. But on the analysis settings screen, like I was saying, the basic idea is to keep things really simple at the very highest end. So really, we can make this a push button, 2-button process where you can actually get valid results. But then, of course, we need to be able to get under the skin to open it up and to be able to set things, customize things where we need to customize them. So at the highest level, we've just really got one setting, which is the analysis type. And now we've got 2 analyses to choose from, the 2 lead analyses, and everything else is set. So we automatically look up the weather data for your project location. We pick the right days that are clear days, and we use those solar values. We set the thresholds for you, and then, like I said, the engine chooses the quality properly. And then the second part, the generate results, we basically have chosen a set of results which are useful for design and also needed for lead submittal. And then beyond that, you can start to kind of peel back the skin and get to some other layers of the baseball. And you can dig as deep as you want. I'll show you some of the layers here. The default view, the default analysis visualization view is this gradient view, which looks nice. It gives you a very good spatial representation, but a lot of people want to see the individual points to really see what's going on. So at the low resolution and high resolution, you can actually change the AVF settings to see the values of every single point that the gradient was generated from. And then, of course, these are results that you're typically not going to look at to make design moves on, but you can, looking at the data down at the schedule level, you can start to understand the results in each individual room and start to look at areas where you might want to do more detailed work. Now, the first window that comes up when you're doing the analysis is we give you kind of a list of things you should look at, and each one has a link to a help topic where you can dig deeper. I can go over a couple of these. One of the most important things is to set your materials right. What I tell most people is really the only thing you need to do before you click Run Analysis is to set your glass transparency. The opaque materials are generally pretty good. The default materials that we use in Revit are pretty good. Everything else is pretty much what you see is what you get. Really, the way the tool interprets materials is generally a little bit better than what people would judge to be the reflectivity of a surface. So it's best to go with the opaque materials defaults. For the glazing surfaces, the default glass is usually much too transparent. So if you want to put in the values that you're actually going to probably be using in your model, you need to go in and set the transparency and the appearance settings. And I would suggest you go to the help topic for that because it's a bit of a convoluted process right now that we're working on improving. Then if you want to go on to set more detailed settings, we actually respect what you set up in your 3D view. So we want there to be a direct connection between what you see in your view and what's being analyzed in the daylighting analysis. So if you if you turn things on or off in your daylighting view, those things are going to be used in the daylighting analysis. And then beyond that, we also have made a config setting for all of these automated settings so that you can turn off the automation and manually set everything during the process. So in the config file, you can basically set all these 1s to 0, and you can set section boxes, you can set the visibility of different objects, and automatic tracking and phasing and design options and all that. You can set those manually. So the engine that's behind this, you asked about, is the same engine that's used in the render in the cloud service. So the first place that we implemented the daylighting metric result was in the cloud rendering service. So the cloud rendering service will take a 3D view and in the cloud generate a very detailed rendering of the space. We put an option in the output type to render Illuminance, which is basically just an artifact that's generated along the way of creating a visual artifact. And you can, for any 3D view, you can get an Illuminance rendering. And you can see that the settings on this dialog are much more detailed, where you can actually choose, any time of day, any day of the year. There's a number of sky models you can choose from, including a daylight factor sky, a CIE sky, the Perez distribution. So if you could create a camera view, a 3D camera view, you can create an Illuminance analysis of any day, any time of year with that. So I would call this a deeper layer of the baseball where you can dig under and get more detailed information. You're not going to be able to get this information into Revit in the same way as the lighting analysis tool, but if you need to do more detailed analyses, this is one way to do it. Another thing, during the process of developing the plugin itself, we first develop all the capabilities of the individual components of it in Dynamo, which, if you guys don't know, Dynamo is a visual scripting tool for Revit, where you can go through and each of these boxes or nodes has a function, an input and an output. You can string them together to automate things in Revit. So the first thing we did to develop the plugin was we developed all these nodes that do lighting analysis in Dynamo, and we actually wrote the plugin in Dynamo first. So now these are available to you, so you can create your own customized plugin functionality using Dynamo nodes or any other custom functions. And there are quite a few good examples up on the Dynamo site of people that have used rendering and daylighting nodes to do different analyses. So here's an area where you can get get out the detailed information about certain points in your building, maybe feed those back into your building and automatically change glass or shading device depth or something to create optimization processes. Now the last bit I wanted to talk about is validation of the tool. Since this is an engine that we developed ourselves, we really have the responsibility on us to prove to everybody that this is as good as what everybody expects to get out of something like Radiance, which I would call the industry standard. So a couple things we did before we started development of the lighting analysis tool is to validate the sky model. Here's just a couple charts that represent the distribution of diffuse and direct solar values in real weather data. And the middle line and the distribution there is what we generate when we look at the global horizontal irradiance, for instance, on a horizontal surface from the sky model, from the virtual sky model that we create. So a very good correlation on the sky model. We also had a model of the office I used to work at where we had a really good radiance model that we had calibrated to actual readings in the space. So we could basically compare the rendering and lighting analysis results to measured results and to radiance at the same time. And we got very close correlation on that. We can see a couple of differences, which is what we'll be fleshing out in this validation project we're working on now, where, for instance, here, the way that radiance and the way that lighting analysis tool models glass is slightly different, whereas radiance uses a single plane and then a distribution based on a BSDF or a standard distribution. We actually model the thickness of glass and model the physical way that light moves through glass and refracts and distributes. So we've got a little bit of different response right near the glass surface. But in general, we're getting a very similar results. So recently, we've hired SQ Dumez and Ripple, actually a local firm, who's got Jacob Dunn, who actually we have here today, formerly worked at the Idaho Design Lab, doing a lot of daylighting analysis. We've hired them to do a validation project, a pretty extensive validation project on the tool, and actually let Jacob come up and tell you about that part.
All right, thanks, David. As he mentioned, I used to work for the Integrated Design Lab up there in Boise, Idaho, doing a lot of energy efficiency research and consulting, and I was recruited out of there to come into SQ Dumez Ripple to really integrate with their design teams and try to bring a performance-based design practice to what they were doing in terms of a lot of high design work. And one of the main reasons why we thought that was possible, I think, is a lot of the evolution in where the tools of kind of the BIM to SIM modeling process is. We're finally able to get a feedback loop that's fast enough to integrate into some of these professional projects with their crazy timelines and multiple deadlines. So all of this kind of idea is predicated upon the LAR analysis tool that David mentioned and a lot of the new workflow from the energy modeling side. So we're really excited about trying to incorporate those in that design process and are really interested in accuracy of the tool and kind of some of these workflow concepts. So we are partnering with David Scheer to do some of the hardcore validation, then also with TRC, which is formerly known as the Hirschong Mahone Group, and we're working with Moody Saxena on doing some of the more statistical analysis of some of those validation studies. So between TRC, Autodesk, and SQ Dumez Ripple, we're kind of working on the best way forward to produce something that would give the industry confidence in using the tool. So really that kind of takes two forms. One is the engine validation, the multiple light ray cuts or whatnot, like that particular physics. How can we start to validate that engine against industry standards, against radiance, against some of these methodologies that exist to give us that confidence that we know the physics behind the tool is correct. And then the other side is the workflow validation, which is really about accuracy with these simulation programs are driven by two things: the underlying physics, and then equally as important is how we use the tools as practitioners or as the actual end user. And as we start to integrate a lot of these analysis inputs, a lot of the material specifications within the BIM environment, it becomes absolutely critical that we have a QA/QC process, right? That we know what we're specifying, so it's not just garbage in, garbage out, that we really understand what we're simulating. And that starts to get clouded by automating that process, which is a really useful thing to do. But there's this balance between how much you show, how much you actually touch. So the engine validation is based upon the Christoph Breton 3ds Max validation paper that some of you might know about. It was essentially a third-party study where they were looking at comparing the 3ds Max daylighting engine to Radiance, so we're kind of following that methodology. And we'll talk a little bit more about that in detail. And then the workflow validation is really looking at taking real-world models, running comparisons on that, so we get some of the geometric complexity of the real world and not these kind of simplified validation or lab models, and also looking at some of the sensitivity studies that we might encounter through workflow. So those are the two things that the validation focuses on, and I'm going to go ahead and give a slight prospectus of what that looks like. So in terms of the engine validation, So the goals, we're actually adding on to the methodology of the Christophe Breton 3ds Max paper. The actual methodology that we're using, they're comparing the simulated results to actual data from a measured laboratory building from the NRC, which is the National Resource Council over in Canada. And so this space has a lot of well-documented data that they can compare their simulations to. And then, of course, we're having TRC, since SQ Dumas Ripple, we're architects. We're not statisticians, so we're actually having a firm do some of that heavy lifting to make sure all the error bars and correlations are within reason. So the actual test bed, this is a photo, sorry, sensitive. This is a photo of the lab space, so you can see that it's pretty simple. A lot of the validation models try to reduce the amount of errors possible, so they're generally very simple spaces. You can see they've got grid sensors that line the floor, there's some on the ceilings. They have really good measured data from the entire year. They have measured irradiance values, so we can plug that into the simulation. And once again, it's just really, really simple, so we can really compare the engines of the simulation program to the actual data that we measured from the sky. So in terms of just a little bit more detail in the study, they looked at that simple box and they swapped out the facade for kind of 5 different test cases that varied in complexity. So they had just test case 1, which was just normal window configuration. Then they looked at adding a translucent light shelf. They looked at adding 2 types of interior and exterior blinds with different kind of curved geometries. So they went from very simple to pretty complex pretty quickly. So there were 5 test cases. They did it over the course of a summer, essentially, so 70 days. They went from 4 a.m. to 4 p.m., 15-minute time step intervals with multiple sensor point locations. So I think it's something like 60,000 points of data that they were then trying to do some statistical analysis to make sure that they were within reason to the measured value. So that's kind of the hardcore engine validation trajectory that they used and that we're going to mimic. So they really broke it down into 2 different things. They have these daily profiles, which is the graph on the left, where they're looking at the measured value versus the simulated value, so they can get a visual correlation of what's going on. And then all of those data points feed into a more robust analysis, which is mean biased error analysis and root mean squared error analysis, which is really just 2 different methodologies that try to quantify the magnitude of error. So they plug all those 7,000 or 70,000, 60,000 points into these equations, and they get values that they can then use to quantify it. So we won't get into it any more than that. So then moving on to the workflow validation, which we're definitely really interested in as practitioners and as users of the tool to try to affect design. We've kind of studied it to handle 3 different things, right? So we've got real-world models, the sensitivity studies, and also we're trying to analyze them under the lead percentage threshold values, because that's the main metric that we're going to use for a design feedback loop. So what is the percentage values and how do those match up? And then also we want to look at kind of threshold distributions. So spatially, is it telling the story versus just at these kind of abstract numbers? Then also looking at section illuminance profiles, because we also are very interested in the vertical distribution of the daylight as well. All right, so for the real world models, we have a really rich data set coming from TRC. And essentially, they've developed really detailed radiance and ecotech models of over 61 actual spaces all around the US for the Public Interest Energy Research Project. So doing a lot of kind of energy upgrade analysis on public buildings and to kind of understand savings, feasibility, and potential. And so they're allowing us access to that data set so we can start to build Revit models of those spaces, run the comparisons, and then also compare them to the radiance simulations so we can get some really granular comparisons of real-world energy simulations to the new Revit tool. And you can see that these are a little bit more complicated than the simple box from the NRC study, and they actually have skylights, there are clear stories, they're representative of actual spaces out there in the real world. So we think that adds another layer of confidence to the accuracy of the tool if we get them to line up, right? So here's just a quick example of some preliminary studies of kind of testing that concept. So on the right is an ecotech radiance model that was provided, and you can see that the model has skylights, that has baffles, it's got corner glazing, 2 different curtain wall systems, and then it has a fairly large overhang that prevents any direct sun from getting into the space. So, fairly complex in terms of the different daylighting systems that are incorporated into that particular model. You can see on the left, we tried to reproduce it, model it as accurately as possible with Revit. And then running the different simulations, we looked at the threshold, the percentage of the area above, in this case, 1,000 lux, because they were both pretty much completely daylit. So we changed the threshold value to understand, okay, are they lining up? If we hit that run analysis button, we're getting these values, are they close or are they within reason? You can see that they're only about 1% off in this particular example, but the spatial distribution is telling a slightly different story, so we need to kind of investigate that a little bit more. We can start to run it with and without the skylights, with and without the baffles, to kind of see where some of that discrepancy is happening, and we can start to analyze all those different cases across as many of those 61 models that we can model with the budget that we're given. So that's kind of the spatial distribution. Here's another kind of early validation study that we were doing to try to test the waters of whether or not we believed the tool's outputs. And this is kind of a section distribution analysis. You can see in the floor plan that we took a kind of a line of those sensor points and compared 3ds Max to Radiance to the LAR models as closely as we could to start to understand, just at a glance, kind of a sniff test, if we can start to incorporate this into our workflow. So these types of comparisons were, I think, really useful, and it's something that we'll carry on into the actual validation study. And then, so there was the slice analysis, there's the overall threshold, and then we can also do some fairly detailed analysis on all of the grid points, since we're able to kind of open up the back end of the data and get all of the illuminance values of all the sensor points. So we can actually take a look at distributions, error margins, and look at the different statistical analyses as a whole. How close is that entire field of grid points matching up to what we're seeing from Radiance, what we're seeing from measured values. So there's a lot of different types of comparisons, but the main goal is really to come up with something that gets you guys enough confidence to be able to say, we should use this tool, we should implement it, because there are these scientific studies and workflow studies that really say that it is within a reasonable margin in terms of accuracy and in terms of workflow. So this, I believe, is David's slide, so I'm going to turn it back over to him. But if you have any ideas on the validation study or what you would like to see from a tool that would give you the confidence to try to incorporate into your workflow, please come talk to us after the presentation. Thanks.
Yeah, why don't you stay up here for a second, in case anybody has any questions. So I just wanted to revisit the general idea here. How do we get the valid and useful results to architects, what that method is in our mind, and then really let's look at the kinds of questions that might come up in a process like this. And I just wanted to open up to questions now, if we've got any more final questions. Yeah. Right, great question. So tubular skylighting devices are pretty much, they're not really possible to model except with like a reverse ray tracing algorithm that's very, very complex. So the way they do it in both Radiance and the way we do it also is to get an IES lighting file, which is a lighting distribution for a particular time of day in a particular place that we put into the model and then treat it like an electric light and just turn that on. So we do have some example models where we show you how to do that. So yeah, it's just a lighting device that has the same distribution as the tubular device would have. Yeah. Any others? Yes. Great. Yeah, go ahead.
So the question was about looking back at some of these section slice analyses, that there were some pretty big discrepancies between 3ds Max and the other two programs in the comparison, which was Revit, or the LAR tool, lighting analysis for Revit, and also Radiance. And in this case, this is just one study in this particular box. But looking back at some of the previous literature, the Christoph paper, there were some larger comparisons around direct sun or indirect reflections in some cases with 3ds Max. So this is just kind of one example. This is just an example of like the types of studies we'll be doing, but it hasn't been really QA/QC'd to make sure everything's locked down. But I would say that it's pretty fair to say that there is a larger discrepancy between some of the cases between 3ds Max and Radiance versus LAR and Radiance as well.
Well, one reason I like to show this image is because it brings up that, basically it's a discussion generator, and it brings up that question, well, how much of this is really the tool and how much is setting up the tool? Maybe we made a mistake, maybe the space is modeled differently. This really outlines why we need to do both a workflow validation and an engine validation. The 3ds Max engine has been pretty well validated, and that research paper has been pretty well accepted as showing that 3D Max is a good daylighting tool. This particular study shows, oh, there's some differences. So, what is that? What that made us do was say, well, we should do a workflow validation to really see where we need to help people build a more valid model. Where we need to say, okay, these are the steps you really need to take to make sure you make a good daylighting model. So this shows basically that on two validated tools, Radiance and 3D Max, they can be very different, and they're not because the tools are bad. Yes? Mm-hmm. Yeah, actually right now it does do both. It does do 3.0 and 4.0, yeah. And we'll, especially if you guys ask us for more tools, just let us know what you want to do, what you want automated, and we'll work on putting those in. And again, if anybody's interested in Dynamo, that's a super powerful tool. You can really make up your own types of analyses, and if you find something that's very useful, we could very well put that into the tool as well. But all right, well. Oh yeah, I'm sorry. I had a couple other slides here. Sorry about that. So yeah, a couple other things coming up. So Revit energy analysis courses are available on the Autodesk.com BPA courses. These are professional courses that we've developed that we've been offering these education student courses for quite a while, and we've developed some professional courses over the last few months. And those are available for AIA and GBC credits online. And there's also a new lighting analysis with Revit course, same situation. It's a professional level course rather than a student level course where you can get continuing education credits. And Stephanie Yeager, who's actually been responsible for creating those education courses and for the professional courses, will be talking later today in this booth right here. So please come back. Stephanie's also will be out there. If you have any questions about the education components of our offerings or any of these courses, please ask her those questions. And thanks everybody for coming today.